In recent years, video game engines have become increasingly more accessible for developers all over the world. What were once expensive pieces of software adopted solely by the AAA video game industry, these are now readily available to anyone with a desire to learn how to make their own games. But a common question that comes my way is what engine should you use if you're going to try and build a certain type of AI system for a hobby project? Or what tools are available in your chosen engine as you're starting out? I'm Tommy Thompson, and in this episode of AI 101, we're going to be looking at some of the most popular video game engines on the market in 2019 and what artificial intelligence tools and technologies exist within each, as well as some suggestions for the types of games you're trying to make. Now let me begin by saying I don't think there is such a thing as the best engine to work with. Let's just get that out of the way. Each have their own strengths and weaknesses and are catering to different audiences. My aim is to give some insight for those of you keen on starting out, as well as provide sufficient kindling to start flame wars in the comments. But in addition, there is a huge disparity between what AI tools are available to developers depending on the engine they decide to work with. Naturally, AI isn't the only consideration you have when making your games, and typically it's much farther down the totem pole once you consider programming language, source code access, physics tools, animation and rendering pipelines, and much more. But it is something worth thinking about depending on the design of the game. For this episode, I've decided to focus on engines that are available to the public either for free or under a license model that's largely accessible. GameMaker Studio, CryEngine, Unity, Unreal, Godot, and Source. So let's work through each in turn and discuss the benefits and drawbacks and even some notable examples that indicate the type of work you can pull off using these tools. So first up, let's talk GameMaker, a fun and flexible 2D game engine that's readily accessible for novice developers. Despite this, it still provides plenty of functionality for more experienced developers to shine, with notable releases in recent years built on the engine including Nuclear Throne, Gunpoint, 10-Second Ninja X, Hyper Light Drifter, and Minit. GameMaker has one notable AI tool, the motion planning system. Any 2D game intent on having non-player characters in it needs to address one critical issue: how to have them move around the world. This could be to hunt down and fight the player, to follow you around as an assisting character, or just run a patrol around the space. The motion planning system enables for navigation paths to be calculated, but with different variations. There are three motion planning function types: linear, potential, and grid. Linear is really simple, it just calculates the straight line path to reach a given destination and start making motions towards it. In this instance, it's looking for a clear straight line path that heads directly toward its objective but doesn't really factor obstacles or anything in its way. Meanwhile, potential is calculating paths that try to go around obstacles. This is based on a principle of potential fields, whereby obstacles repulse the moving object as if they were both magnets. You can configure how far it's allowed to rotate around a given obstacle point. And lastly, the grid approach is using an A-star algorithm to compute a path between start point to end, having broken down the environment into a 2D grid, and it will then calculate the path along that grid that's as optimal as possible. Next, let's check out Unreal, an engine that has transformed much of the games industry in the past decade, becoming one of the most viable options for studios, ranging from indies all the way to the biggest studios in AAA. Unreal Engine 4 is now completely free to use, given Epic Games is making all the money on Earth courtesy of Fortnite, but there are still royalty payments due should a game exceed earning thresholds when published, or if you host it over on the Epic Store, which I'm contractually obliged to bring up so someone can complain about it in the comments and I get my Epic exclusivity money. So let's talk AI tools. First up, UE4 has navigation meshes. While GameMaker works with navigation on 2D surfaces, nav meshes are what we use for movement on 3D surfaces. The navigation volume tools allow you to define whole areas of your game level as navigable for an AI character, as well as justify areas that are more expensive or less desirable to walk through. After that, you can then call the navigation tools to have your actors move around the map. Like all of the AI tools in UE4, you can either interface with the navigation through C++ code, or you can do it through the Blueprint visual scripting tool. If you need to learn more about navigation meshes, be sure to check out the first episode of AI 101, which talks about them in much more detail. Next up is behaviour trees, arguably the most commonly used AI tool for managing the behaviour of a character or system in modern games. Behaviour trees have largely been standardised throughout the industry, and Epic have done a great job of continually updating these tools to better reflect how developers seek to use them. You can build trees of startling complexity, reliant on one or more blackboards to store information that your characters can utilise. Behaviour trees were the focus of the second episode of AI 101, so yeah, be sure to check that one out too if you want to learn more. Working in tandem with the behaviour trees is the Environmental Query System, or EQS. This tool allows you to gather useful information you might need for a behaviour tree to make decisions, such as where enemy targets or items are located, prioritising enemies based on specific properties, and much more. The EQS system is highly flexible, and it can be used to provide information for a variety of different situations. In addition to this, there is the AI perception component that consolidates sensory information for actors. This includes being able to see enemy and friendly actors, being able to hear noises, whether they've received damage from an external source, or even if they're being touched by other actors. That's not meant to sound as creepy as I wrote it, but yeah, they can sense being touched. Unreal's AI tools are arguably the best among all publicly accessible engines for what is typically required in the AAA gaming space, but that doesn't mean they're comprehensive. Despite that, one of UE4's biggest strengths is the access to the engine's source code. This allows for developers to build new tools that integrate within the existing engine framework and can really streamline development. A good example of this was highlighted in my second episode on the AI of Sea of Thieves, where the team explained how they wrote a separate navigation system for sharks, given underwater navigation isn't supported by navigation meshes. However, given the developers integrated it into the existing navigation framework, it meant they could operate it and it could be called in blueprints and behaviour trees much like the normal navigation tools. It's pretty cool. Given we just looked at Unreal, let's take a look at Unity, an engine that is immensely popular with students, indie devs, and even some larger studios given the cost and relative ease with which to prototype games and cross-platform development. It's arguably the biggest competitor to Unreal Engine at this time, with the features in each engine aligning more and more with each new release. Despite that, Unity is, at the time of this video, in a weird space when it comes to AI. Like Unreal Engine, it has a fairly comprehensive, if occasionally limited, navigation mesh system. It has many of the same features as Unreal, but one key differentiator is that real-time nav mesh baking, whereby you recompute the nav mesh during gameplay, isn't supported in Unity by default. However, new nav mesh tools are available via the Unity GitHub pages, and while it seems these new tools will continue to be developed over time, none of it has been built into the main branch just yet. The disappointing thing is that, right now, that's it. Unity lacks tools for managing more complex behaviours such as finite state machines or behaviour trees. However, Unity is investing tremendous resource into new AI research to build new tools that could later be integrated into the engine. So while at present, the engine out the box doesn't cater to a lot of the meat and potatoes of game development, there are two exciting tools currently in preview that you can use right now, the AI Planner and the Machine Learning Agents Toolkit. The AI Planner is designed to provide means through which to build domain models that can model a situation abstractly, then make plans that can execute solutions to solve problems within that encoding. This is very much akin to popular AI tools such as the goal-oriented action planning method popularized by Fear in 2005. The AI Planner is still in preview at this time and only accessible in Unity 2019.2 onwards, and you can download it using the package manager. I'm still playing with it myself, but it seems to provide a useful collection of tools for modeling domains, visualizing plans it's created, managing execution at runtime, but also being able to handle continuous and ongoing tasks. This is achieved through use of trial-based heuristic tree search, a generalized implementation of Monte Carlo tree search, which appeared in my episode of AI in Games when I looked at the AI of Total War Rome 2. This is a really exciting idea, given it will allow for the system to handle situations of uncertainty by simulating the possible outcomes and then plan accordingly. Meanwhile, the Machine Learning Agents Toolkit seeks to allow for developers to train machine learning agents, or brains as they're referred to in the engine, through use of TensorFlow, an open source library developed by Google for training neural networks through reinforcement learning. This requires users to install a working Python setup, whereby you then train the networks through this, then later deploy the trained AI brain as part of the main game. This, like planning, is still in an experimental phase, but could prove valuable once the tools flesh out a bit more. One of the most interesting challenges this faces is integrating the tools for training and testing new machine learning agents into the Unity engine itself. This is continuing to be improved, with new integrations into the OpenAI Gym as well. What's more interesting to me is that the UI and features are built to accommodate this notion of training brains to solve problems within your game, and I'm curious to see how developers will take to that in the coming years. Next up, let's jump over to CryEngine, another feature-rich engine aimed at the AAA market, largely popularised by the Crysis series, but has been in games ranging from Prey to Everybody's Gone to the Rapture. It's worth mentioning that there's also Amazon Lumberyard, which is essentially a separate branch of CryEngine built by Amazon GameTech, but with new netcode hooked specifically into Amazon Web Services and Twitch as well as VR integrations. But I'm going to be focusing on the tools in CryEngine for now. There's a lot of overlap in CryEngine with what you'll find in Unreal, which is no real surprise given they're both vying for the same corners of AAA games development, but the actual implementation varies quite a bit and is governed largely by CryEngine's focus on making first and third person shooters. You have navigation areas that users can define by hand, which can then be utilised by AI actors. Actors can be controlled through behaviour trees that can be defined in XML or in a visual editor, and a unique take on gathering environmental knowledge for your AI known as the Tactical Point System or TPS. TPS is much like the EQS system in UE4 and allows AI to ask intelligent queries about objects or features of the local environment. This is great when you need AI to quickly calculate cover positions that will provide sufficient defense prioritised by distance and whether other AI characters may use them. Arguably the most interesting unique feature of CryEngine is that AI actors can be assigned to territories and waves. Territories are volumes of space built in Editor that are part of what is called an action bubble. When a player enters an action bubble, only AI actors within that territory will be enabled at that point in time. In addition, an AI actor in a territory can be assigned a wave for spawning in and fighting against the player, with new waves only spawning under specific conditions. This effectively manages the spawning, destroying, initializing and debugging of AI actors, and is very useful for creating specific combat sequences. On top of all this, there is also source code access for the engine, so if you need to add and tweak any tools to suit your needs, you can jump in and play about in the C++ codebase. Last of the big engines out there is Valve's Source Engine, which has been used by the publisher for their titles ever since 2004's Counter-Strike Source and Half-Life 2 up to recent releases such as Artifact and Dota Underlords. But is also used by other AAA developers, most notably Respawn Entertainment for both Titanfall games as well as Apex Legends. The public version of Source Engine is accessible from Steam itself and is ideal for making your own mods to many an existing Valve game, but the costs for subsequently making a game based in their engine are a lot higher, given you not only need a Source Engine license, but you need to pay Havoc, whose physics tools are part of the engine, $25,000 before you release the game. So yeah, stick to mods, or go try another engine if you're serious about making a game for sale. Source's tools for AI are largely an extension of that used in Half-Life 2, so it's really focused on non-player characters that fit first-person shooters, but much more layered with additional tweaks and options available. It still stems from the fundamentals of the original game, which I covered in the AI 101 episode on finite state machines, with tasks, conditions and schedules all largely still operating in the same manner as before. Here, there are new additions, with the ability to define behaviours that are effectively generic schedules for different NPCs to adopt, as well as the ability to manage the memory of AI characters and establish relationships between them. Memory allows for information, such as last time the player was seen, or last known positions to be retained for periods of time, while relationships help with squad management and team combat, given an AI character will know whether or not they like, hate, or are scared of another character in the game. It seems like an ideal opportunity to play around with if you're just keen on making small mods. However, I will warn anybody who's keen to try it out, none of the AI is properly documented by Valve. There is a community-written wiki which caters to some of your needs, but it's not entirely fleshed out. Last one on the list is Godot, a free and open source engine which started development back in 2007 and launched version 1.0 in 2014. It's not as popular or as pervasive an engine as the others listed above, but it has a growing community of developers, including school kids in the United States, and there are a small number of games emerging based on the tool. There isn't much to show here, beyond some pretty useful navigation mesh tools, with a lot of tutorials out there to help you build simple steering behaviours or finite state machines. One point to mention is that given the engine is open source, the community does appear to be working on new plugins and tools that could add more features. I even saw a TensorFlow integration similar to that found in Unity that's slowly being developed. But I didn't find much else when conducting my research for this video. That said, I figured I should still give it an honourable mention. This is far from an exhaustive overview of the AI tools available in game engines. There are still engines I didn't cover, and I might have missed something in the ones I did. If you have any thoughts, be sure to share them with others in the comments. But another factor is that so many games are built in toolchains that are not available for the public to use. Most AAA developers or publishers have their own internal engines that are being continually updated to enable for different experiences, be it EA's Frostbite used in everything from Battlefield to Battlefront to Anthem and FIFA, Ubisoft's Snowdrop used in Tom Clancy's The Division and Mario and Rabbids Kingdom Battle, and even the id Tech engine used in Rage, Wolfenstein and Doom. Despite that, hopefully you've got a grasp of what each engine can do, and if you're an aspiring game developer or researcher, you've identified one or two engines you'd like to play with. Thanks for watching this episode of AI 101. If you like it, push all the buttons and join my wonderful subscribers in supporting this show and helping it grow. I'm keen to come back and do another episode on what AI technologies are missing for game engines too. Let me know in the comments if you'd like to see that episode, as it's an increasingly long list. A special shout out to my supporters on Patreon, who not only continue to support this show every month and make all this possible, but it was a discussion in our Discord server that led to this episode being made, along with some valuable feedback on the way. You can join all these wonderful people on screen now by clicking the links in the description. Have a good one, folks. I'll be back.